Hi everyone, welcome back to another video of Math 190, 190, Calculus 1 or Calc 1. This is our first video of this series. Um, I'm going to explain you functions in this video. I know most of you have covered functions or learned about functions in the previous mathematics courses. But since the functions are highly important in this course, and we're going to be using this word over and over again in this course, I thought that it is good to uh, recall you what a function is. Um, in definition, function is a relation that maps each each element of a set. Now, set is another mathematical term. The set is a term that is used to any collection of elements, right? Any collection of elements. You might know sets like a real number set, an integer set, natural numbers, and rational numbers and irrational numbers, right? These are the sets. And there are many other sets as well. Okay. Uh, to a different maps each element of a set to a corresponding unique element uh, in a in another set. The first set, uh, the first set is called the domain. This is called domain. And then the second set, the elements in the second set is called the range. Now, if I graphically show you what this means is that you have a set. You can show a set uh, graphically by using this kind of a balloon or something like that. And you have elements in that set, right? You have x1, x2, x3, x4, and so on and so forth. And this set, I would say, is set X. That's the name for that set, set X. This could be any element. This could be a rational number, irrational number, real number, a complex number, or name, or some kind of value or something like that. Okay, and um, and then you have another set. I will graphically show that another set, and you have different elements in that set. Okay, you have y1, y2, y3, y4, and so on and so on. And I'll name this set as y. This is set y. And our function, there should be a name for that function as well, right? The function, I named the function as f. F is the name of the function, right? And usually the first set, the set in this side, this set is called domain, and the items that corresponds to the the items in the domain or elements in the domain in the in this set is called the range. Okay, uh, this is called codomain, and the items that corresponds to the elements of the domain is called the range. So domain and range. So this set is called the domain, and the items that map into this set is called the range. Okay, and and then also this side is called independent variable, and this range is called dependent variable. So that also another term that they use. And usually we say function of x. That's the independent variable of the function. Function of x. So this says function of x. Now, I would like to recall that you have learned some other functions. For example, trigonometric trigonometric functions, sine. Instead of x, f, you have sine of x. Cosine, that's this f, the name of function sine, the name of function cosine of x. And you have seen tangent of x. And then you have seen logarithmic function. The name of the function is log, base 10 log x, and you might have seen ln, natural log of x, right? And again, this independent variable could be anything like, instead of x, you can use p, q, whatever that you like. And you might have seen exponential functions. E of x. The E is the name of the function. Sometimes some people write exp of x, right? Exponential of x, so on and so forth. Okay, so that's just names, some different names of functions. It's not always f of x. F of f is a very generic name for function. And then you might have seen, some examples. Some not. Another examples are polynomial functions. The polynomial functions could be linear or could be quadratic functions, or maybe cubic. So you have some degree of polynomial, right? This is first degree, second degree, third degree, and so on and so forth. Polynomial functions. You can write them as f of x equals, if it is a linear function, you can write f of x equals x plus 4, something like that. Okay, these are examples. And you can also write g of x is equal to x squared plus 2x plus 3. Okay, so what does what does this definition means? So in a function, if this relation, this could be any kind of relation. In this relation to become a function, this each element should go to a unique element in the range or the codomain. Uh, it could be like this as well. Now x1 and x2 can both map to y1. It doesn't matter because x2 represents a unique element y1 and xy represents a unique element xy1. And x3 can map to y3 and x4 can map to y4 and y5 or whatever, depending on what the relation is, what the function is. However, None of the elements in domain can map to two elements in the codomain. So something like this cannot happen. Now x3 now already mapped to y3. If f3 maps to y2 as well, then that's not a function. If this happens, that's not a good, that is just a relation, it's not a function. Okay, that's the key thing. Uh, Two elements in the domain can map to the same element in the range, but uh, one element in the domain cannot map to two different elements in the range. Okay, so that's the key to understand. So for example, this could be a function. So I will draw you and show you graphically small here. So this is another example. You can write like that. So you have elements here, P1, P2, P3, which map to Q1, Q2, and Q3. Uh, let's consider like this. So P1 map to Q1 and P1 map to Q2. That's not a function, not a function, not a function. Okay. Um, but this could happen. But this could happen. Now let's say you have um, R1. Hold on. Let's use another color. We have R1, R2, R3, S1, S2, S3. So you can map this to R1, and R2 can also map to S2, right? And that can map to this. So this is a function. Now, how do we determine this? There's an easy way or graphical way of determining this. We call that vertical line test. Vertical line test. So in the vertical line test, what we do is um, for example, let's say this. So if you have a function that graphically looks like this, right? So if you draw a vertical line at any x location that has two values of y. This is x, this is x-axis. Let's say the x equals a, y equals b, and negative b or something like that. Okay, so in that case, this is not a function. So any vertical line drawn across at any x location intersects the graph of the function at two different y locations. This says the vertical line test fails. So that means this is not a function. Okay, let's take an example. Let's take an example. So we're going to do a lot of examples in this class, so that will help you to understand the concepts. We're going to talk about the concepts and we're going to do the examples. Sometimes we take examples and then we lead our way to the concept, okay, depending on how difficult the concept is. So I have example f of x equals x plus 4, or sometimes you can write y equals x plus 4. The both are the same, okay? F of x, function of x equal to x plus 4. So the items in the domain maps to the items in the codomain, or they called range. Um, and um, Now, is this a function? Or let's do the vertical line test. Let's do the vertical line. Let's do that. And you already know from pre-calculus, and you learn how to draw the graphs. Uh, y, x, or you can say this is f of x, right? So you have a constant vertical, sorry, straight line that intersect at y equals 4, right? So this is 4 here, and uh, this is the line. So you draw the vertical line test. It does not intersect the curve or the graph at two distinct location at any x value. So this is a function. What are the all possible values that satisfy this function, or what are the all possible values that x can take? Is the domain. All the possible values that x can take, right? Uh, to define fx properly, right, uh, is called the domain. So for this one, is domain is whole real numbers, so negative infinity to positive infinity. What is this infinity? So this notation is also important. This is called infinity. Infinity. This is merely a symbol to uh, say that this is a very large number. So if you have positive infinity, usually you don't put positive sign, but sometimes some people put positive sign. That means a very large positive number. A negative sign signifies a very large negative number. And these are not really numbers, okay? You cannot do usual mathematical operations with these symbols. It's just a symbol. Remember that. Just a symbol. Okay? And it's not valid to do infinity plus 1 equal to infinity. Well, sometimes you can take that, but it's not mathematically correct that you write like this. Okay? Okay. Let's take another example. Number 2 example. Um, you have y equals 2x plus 1 square root. Oh, square root of 2x plus 1. So now y, or you can define it as fx. F of x is equal to 2x plus 1. Um, Now f of x should always have a real value, okay? A real value. So what if the content inside the radical is negative? So if 2x plus 1 is less than 0, that means f of x, for that values, the function is not defined, because now it becomes, if you have negative value inside the radical, it becomes complex value. So these are not real numbers. So in that case, the function is, if this happens, for these values, function is not defined. So the f of x should always get a real value. Okay, real function. It's called real function. There are complex functions which are not. We are not going to talk about that in this lesson, right? But this is a real valued function, not a complex valued function. Okay, it's a different story. But In this case, we think, okay, we have to define the domain such that this f of x is a real value, right? We have to define our domain. We have to pick values of x so that f of x becomes real. Okay, so we pick our domain. We can pick our domain. Okay, if we pick a wrong value for x, then we ended up in getting a complex value. So how do we pick? So we know that if fx to be defined, well defined, then 2x plus 1 should be greater than or equal to 0. Oh, inequality. Have you talked about inequalities? Yes, you have. So there are some rules that you uh, use when you're dealing with inequalities. So we can add and subtract without changing the inequality. Plus 1 minus 1 is equal to 0, and then you have 2x greater than or equal to negative 1. Okay. Oh, I'm sorry, I should have written. Okay, that's fine. Uh, Now we have 2x uh, greater than or equal to negative 1. And then you can divide by 2 both sides. You divide both sides by 2, and you get x greater than or equal to negative half. So if I recall you this thing, this is called real line, goes to negative infinity to positive infinity, and then you have somewhere in the middle you have 0. Okay, and then you can indicate that this is negative half. And how do you note that negative half is included? So you have to color that bubble right there, right? And then after all the values greater than, all the x values greater than negative half is can be taken to the domain. If you take any x value, right here, or less than negative half, that makes this function undefined. Okay, that makes this function undefined. That makes sense. So we have to pick our domain. Our domain in this case is equal to the values from we can say that x should be in between uh, the closed brackets. We draw a negative half to positive infinity. Positive infinity we put a parenthesis because that's an open interval. This is called closed interval here, right? This is open end, this is a closed one. Closed one using a bracket, okay? In open one is a parenthesis. Okay, so let's take this as an example. Let's take this one as an example. Uh, so this is a function, and its domain is this, and what is its range? What is its range? What could be its range? So can this be negative? No. It should be always a positive value, right? So where does it start from? If you put half, negative half, this becomes 0, and all other values, right, greater than negative half, this is a positive value. So your range is, so your y is from 0 to positive infinity, right? 0 to positive infinity. So that's your range, right? It cannot be negative, right? This is how our domain is defined. Okay, so you find the domain and range. Okay, let's take another example. Uh, for example, take this one. F of x equals 5 over x minus 1. 5 over x minus 1. Um, so we can do the vertical line test if we know what the graph of this function is. Um, now we can see that this is a function. Um, when it goes to, you can draw, and you can say this is y equals 5 x minus 1. X equals 1 is a critical point for that. Not a critical point, actually. X equals 1 is in vertical asymptote. I'm going to talk about this vertical asymptote. I'm sure that you might have done this in pre-calculus. Now, what happens when x become closer to uh, 1? It becomes very large number, right? And when x goes to infinity, y should goes to 0. So it should look like that. And if y equals 0, that means here, if y equals 0, then uh, yeah, it doesn't mean anything. If x equals 0, then means y equals negative 5. So this is 0. So y equals this is 1, 2, 3, 4, 5. This is negative 5. And when y becomes closer to uh, y sorry, x goes to negative infinity, this would negatively become 0. So it should be something like that. Okay. So you can draw any vertical line test that does not intersect the graph of the function at two distinct y locations. So this is a function. This is a function, and you can see that the value of f of x at the value of f of 1, right, is not defined. So we need to exclude that, right? We need to exclude that from our domain. So our domain is negative infinity to 1 and right, and then 1 to uh, positive infinity. And you can see that in the range y equals 0 is this line, right? The curve or the graph does not intersect y equals 0 at any location, right? So what happened? The range is excluded 0. Okay, so the range is that. Range is that. See that this is y equals 0. This is y equals 0, right? The curve does not intersect y equals 0 at any point. So the y equals 0 is not included in the range. Y equals 0 is not included in the range. Uh, let's take another example. This is example 3, and this the 4. Example 4. So in example 4, uh, I will take y squared is equal x. So y squared equal x curve is something like that. This is y. This is x. If I draw the curve, it should look like that. Right? Y squared equals x. So we can see that if I draw vertical line at any x location, it intersects the curve at two different y values. So this is not a function. And but we can get the range in the domain. So you can see that range domain, that the values of x, right? You can see that all the positive values of x domain is 0 to positive infinity, because 0 is included. 0 is included. But the range can go from, this is negative infinity of y, this is positive infinity of y. So right, it can go to negative infinity to positive infinity. And that's the range. Okay, that's the range. Um, Another example, another different type of example. Another different type of example. That's y is less than or equal to x minus 1. So when let's take this as an example. When x equals 1, y could be what? Y could be when equals 1, this is y could be less than or equal to 0. So y could be 0, y could be negative 1.5, y could be negative uh, zero point 0.9, anything, right? So for one value of x, you have multiple values of y. So this is not a function. This is not a function, right? Um, and you can say that domain and range could be um, positive, negative infinity to positive infinity in this case. Okay, so that's about finding a function, definition of function, and vertical line test, and uh, also uh, and also domain and range of the functions. Okay, so let's look at even functions. Okay, even functions uh, and odd functions. Even functions and odd functions. So if you have a function of x, right? If we can write f of negative x is equal to f of x, that's called an even function. And if you have f of negative x is equal to negative f of x, that's an odd function. Okay. Uh, some functions are um, even, some functions are odd, some functions are neither uh, even nor odd. So even functions are even the graphs of the even functions are symmetric about y-axis. For example, this y equals, oh sorry, or f of x equals x squared, okay, uh, plus 4. Let's say x squared plus 4. So how do we draw x squared plus 4? Can we draw the graph of x squared plus 4? Yes. So you have f of x. Uh, this is at x equals 0, it's 4, right? So you can see that this is the function, vertical line test uh, passes, and you can see that f of what is negative 4, sorry, negative 2 is equal to 2 squared, 4 plus 4 is 8, and positive 2 also 8, right? So this is symmetric about y-axis. So that's an odd function. So you can say f of x, f of negative x, I substitute negative x instead of x square x. So negative x squared plus 4. Negative x squared is again x squared plus 4. So this that is equal to f of x. So it's a even function. And I have another function f of x. F of x equals x cubed. F of x equal x cubed minus x. Let's say that. Uh, right. So then you can write f of negative x, which is equal to negative x cubed minus negative x, right? Um, so this becomes negative x cubed plus x. So you can take out a negative sign, x cubed minus x. This is what? Negative f of x. So this is a odd function. Sometimes some functions are not even, neither even or nor odd. So we can draw a graph like that, um, and you can see some graph like that. So you have x value here, negative x, and x value here, two different values. neither odd nor even. Okay. And odd functions, the specialty of odd functions is that the graph is symmetric about the origin. The graph is symmetric about the origin for odd function. The graph is symmetric about the uh, origin. Okay, that's a special case. That's a specialty in odd functions. So that's all about odd functions. Let's do another example to find a domain of a function. So let's do this example. Uh, I'll give you a couple of minutes to maybe 5 minutes, 3 minutes to do this one. F of x, sorry, f of x is equal to uh, square root of 4x plus 1. Take your time, uh, 5 minutes. Pause the video here and take exactly 5 minutes, and then come back to the video and see what the answer is. Okay. Okay. I hope you pause the video and did the example by yourself, and here's the solution for this. So as I explained earlier, this content inside the radical should be greater than or equal to 0 to define function f of x. So this 4x plus 1 should be greater than or equal to 0. Okay, so you have 4x plus 1 minus 1 greater than or equal to 0, greater than or equal to minus 1, right? And then this becomes 0, and 4x greater than or equal to negative 1, and x is greater than or equal to negative 1 fourth. Okay, um, and that means if I draw the real number line, this is 0, this is negative infinity, this is positive infinity. So I have negative 1/4 here. So all the values including negative 1/4 and beyond is in the domain. So domain is bracket negative 1/4 in plus infinity. And the range, what is the range? Range is actually from 0, it can assume 0 value when x is equal to negative 1/4, and beyond that it goes to positive infinity. Okay, this is how we decide range and domain function. Okay, I hope you understand what the functions. So we talk about, we define functions. Functions are relations that maps each element in the domain to a unique element in the range or the codomain. Define functions. We define the functions, and then we uh, talk about how to find domain and range, and then we did vertical line tests. If vertical line test passes, that's a function. If not, it's not a function. And then we talk about odd and even functions. And we did some examples as well. Well, thank you very much for listening, and hope you'll join the next video or in class. Thank you very much.